Between the jet fighter runways and the constant noise of activity on the flight deck, here's a small but interesting feature that's easily missed: a hole that constantly lets water out. But what's the point of this strange hole? Does it just drain rainwater, or does it hide a piece of tech that's necessary for the ship to work? Modern aircraft carriers are, of course, engineering wonders in and of themselves. They have to be huge and long to meet modern naval aviation's needs, after all. When fully loaded, these behemoths can be over 1,000 feet long and move more than 100,000 tons. It's pretty crazy, right? Their huge flight decks have plenty of room for planes to take off and land, and their advanced catapult and stopping gear systems make sure that flight operations are safe and efficient. There are many maintenance facilities, fuel and ammunition storage, living areas for thousands of crew members, and advanced command and control centers below the carriers. You can't say enough good things about aircraft carriers. They're the most important part of current maritime strategy. These floating air bases give countries unmatched freedom and reach, letting them project power across huge swaths of ocean and impact key areas around the world. When there's a war, carriers are very important for both offensive and defensive operations. They help ground troops from the air, attack enemy targets from the air, and keep maritime superiority by being incredibly present. Aircraft carriers are also a sign of national pride and protection because they show how strong a country's military is and how committed it is to protecting its own interests on the world stage. In addition to being important to the military, aircraft carriers are also essential for disaster aid and other humanitarian missions. Their quick ability to send planes to remote or disaster-stricken areas lets them respond quickly and help people in times of crisis, like natural disasters or humanitarian situations. Aircraft carriers show their versatility and ability to do good in the world beyond their usual role in war by delivering supplies, evacuating civilians, or giving medical aid. Design and structure aircraft carriers are carefully made to meet the specific needs of naval aviation. The main part of an aircraft carrier's design is its layout, which is carefully planned to make flight operations, repair tasks, and support tasks run more smoothly. The carrier's most noticeable feature is its flight deck, which covers most of its upper surface and is equipped with stopping gear systems and catapults to help planes take off and land. The flight deck makes sure that planes can take off and land safely, which is important for the carrier's continued operations, as lost assets would be incredibly expensive. The hangar deck is a large room below the flight deck inside of the carrier's hull. This is where planes are kept, maintained, and prepared for extensive missions. The hangar deck is where the carrier's aviation operations are centralized. It has workshops, places to store fuel and ammunition, as well as maintenance facilities. Spoiler alert, there are millions and millions of dollars worth of aircraft and equipment in the hangar deck. But if you go even lower beneath the surface of the hangar deck, the hull of an aircraft carrier forms the sturdy foundation upon which the entire vessel rests, and this is where these small holes come into play. One interesting thing about the carrier's hull is that it has strategically placed holes that people often mistake for weaknesses. These holes, which are called sea chests or entrances, are very important to the carrier's ability to work and stay alive. Despite what some people think, these holes do not threaten the carrier's structural stability. Instead, they make it easier for it to do its job. Seawater can get into the carrier systems through these holes and do important jobs like cool machinery, provide ballast, and help the ship move. They play a vital role in ensuring the carrier's continued operation and maneuverability, exemplifying the ingenuity of naval engineering. When we look more closely at what these holes do, We see that they let seawater flow through and cool the ship's engines, like the steam or gas turbines. By allowing seawater to flow into the ship's intake systems, these openings enable the efficient cooling of machinery, avoiding overheating and ensuring the uninterrupted operation of critical propulsion systems. The openings also serve as ports for the desalination plants on the carrier, which turns seawater into potable water that the crew can drink. Seawater is needed for the desalination process because it contains the minerals that are needed to make fresh water on board the carrier for drinking, cooking, as well as other important uses. In addition, these holes could be used as discharge ports for different types of waste streams, such as wastewater and ballasted water. These holes let out the wastewater that comes from sinks, showers, toilets, and other places on board the carrier. This keeps the ship clean and healthy. In the same way, these ports can be used to release ballast water, which is used to keep the carrier stable and in the right position during different operational conditions. So the holes in the carrier help keep the ship working and ready for action in a number of ways, which shows how important they are in naval engineering. The small hole, a seemingly unnoticeable feature on an aircraft carrier's deck, is the small hole. This small aperture is very important to the carrier's overall operation and usefulness, even though it doesn't look like much. Situated strategically across the flight deck and other operational areas, the small hole serves multiple purposes that add to the ship's efficiency, safety, and stability. The primary function of the small hole is to facilitate ballasting and stability control on board the aircraft carrier. To keep activity safe and running smoothly, the carrier must keep its balance and stability as it moves through the changing sea environment. The small hole allows excess water, whether from rain, seawater splashes, or washdowns, to drain from the deck, stopping it from accumulating and affecting the ship's stability. By regulating the distribution of weight and buoyancy, the small hole helps to maintain the carrier's trim and stability, important for maneuvering and operating effectively at sea. Moreover, the small hole also serves as a vital component of the carrier's drainage system, stopping water accumulation on the surface in the challenging maritime climate water. It also stops ingress from various sources including grain seawater spray and operational activities, which is often inevitable. Insufficient drainage systems can result in water buildup on the deck, which can cause serious problems like deterioration of the deck's materials, less traction for flying, and possible worker safety issues. A tiny hole serves as an outlet for extra water, enabling it to drain quickly and effectively, reducing these dangers and guaranteeing the carrier's operating readiness. To fully appreciate the significance of drainage on an aircraft carrier deck, one must take into account the possible causes of water buildup. Rainfall can cause substantial amounts of water to accumulate on the deck surface, especially in bad weather or severe conditions. Water buildup on the deck can also be caused by seawater spray from operations like ship maneuvers and airplane takeoffs and landings. Moreover, water runoff from standard maintenance tasks like cleaning the deck or maintaining aircraft may also arise and need to be properly controlled. These water sources could jeopardize the carrier's operational effectiveness and endanger both people and equipment in the absence of sufficient drainage. Beyond operational effectiveness, keeping the deck dry also takes into account more general safety concerns. Due to its ability to reduce aircraft traction during takeoffs and landings, a wet and slick deck can cause serious dangers to flight operations, including accidents and catastrophes. Furthermore, water buildup on the deck surface makes it more likely that the materials will corrode and deteriorate over time, requiring expensive maintenance and repairs. The small hole helps to ensure that the carrier is more operationally ready overall by reducing the risks connected with water accumulation and providing a quick and easy way to remove excess water from the deck surface. This hole, an essential part of the ship's infrastructure, is a prime example of the engineering, creativity, and painstaking attention to detail that defined contemporary naval vessels. Given the possible effects on coastal areas and marine ecosystems, Water discharge from aircraft carriers has substantial environmental ramifications. Aircraft carriers produced wastewater and ballast water during ordinary operations and deployments, which necessitates its disposal as a vital component of naval operations. However, there are dangers to biodiversity, water quality, and ecosystem health when this water is released into maritime ecosystems due to the introduction of pollutants, contaminants, and invasive species. Therefore, reducing the negative effects on maritime ecosystems and maintaining environmental sustainability requires reducing the environmental impact of water discharge from aircraft carriers. Many steps have been taken to reduce the environmental impact of aircraft carriers' water output in order to reduce these worries. Using cutting-edge wastewater treatment technologies to treat onboard wastewater before discharge is one of the main tactics. To ensure the wastewater complies with environmental norms and laws, these treatment systems use filtration, chemical disinfection, and other procedures to eliminate impurities and pollutants. These systems lessen the concentration of dangerous materials and the chance of pollution when wastewater is released into the maritime environment by treating it on board the carrier. To stop the spread of viruses and exotic species, strict policies and procedures also control how ballast water is released from aircraft carriers. When ballast water is used to keep a carrier stable and trim under various operating conditions, it can unintentionally spread non-native species throughout marine environments, upsetting biodiversity and ecological balance. Carriers use ballast water management plans, which involve exchange, treatment, or retention techniques to reduce the spread of invasive species. These techniques lessen the ecological effects of ballast water discharge while preserving natural habitats and marine biodiversity. In addition, continuous research and development endeavors concentrate on the progression of eco-friendly technologies and methodologies to lessen the detrimental impact of aircraft carriers on the surrounding environment. Among them is the investigation of substitute propulsion mechanisms like electric or hybrid propulsion to reduce operating emissions and fuel usage. Furthermore, efforts are being made to improve resource consumption and reduce waste generation on board the carrier through advances in trash management, recycling, and resource conservation. Naval forces work to reduce their environmental influence while preserving operational effectiveness and readiness by incorporating sustainable practices and technologies into carrier operations. Naval forces are essential to protecting marine biodiversity and maintaining the health and integrity of marine ecosystems for future generations, since they are the stewards of the seas. Procedures for maintaining the small hulls on aircraft carriers are essential to guaranteeing the drainage system's continuous efficacy and operation. The tiny hull is an essential part of the carrier's architecture, thus it needs to be regularly inspected, cleaned, and maintained to avoid clogs, corrosion, and degeneration. Regular inspections, preventative measures, and remedial activities to quickly resolve any problems or defects are usually included in maintenance processes. First, visual checks are carried out regularly to determine the state of the small hull and spot any indications of corrosion, damage, or obstruction. Crew members search the surrounding region for foreign items, debris, or sediment accumulation that could obstruct water drainage or jeopardize the drainage system's integrity during these inspections. Periodic cleaning and flushing of the small hull is necessary in addition to visual examinations to get rid of accumulated debris, sediment, and biological development that can impede drainage and hinder water flow. Using specialist instruments like brushes, scrapers, or pressure washers to loosen and remove tenacious deposits from the tiny hull and its surrounding components may be necessary during cleaning procedures. To dissolve organic debris or stop the growth of algae, barnacles, or other marine creatures that could obstruct water drainage and lead to corrosion, chemical treatments can also be used. Preventative maintenance procedures are also carried out to shield the small hull from deterioration, such as erosion, corrosion, and other types that may eventually jeopardize its structural integrity and its performance. One possible solution to reduce the impact of exposure to seawater salt spray, and environmental factors in the small hull and its surrounding components could be to apply protective or corrosion-resistant coatings. Furthermore, consistent lubrication of moving components, such as hinges and valves, ensures smooth operation and guards against wear and corrosion that could compromise the drainage system's efficacy. The tiny hull's crucial to the aircraft carrier's overall performance and efficiency for several reasons, which makes its upkeep imperative. Keeping the small hull maintained properly lowers the likelihood of slip and fall incidents and improves operating safety for both staff and equipment by ensuring efficient water drainage and preventing water accumulation on the deck top. The small hull serves to maintain ideal conditions for flight operations, maintaining aircraft traction during takeoffs and landings, and reducing the possibility of accidents or incidents on the flight deck by permitting the quick drainage of surplus water. Furthermore, keeping the little hull maintained is essential to maintaining the carrier's infrastructure's longevity and structural integrity. Maintenance practices contribute to the drainage system's extended lifespan by halting corrosion, erosion, and degradation of the small hull and its surrounding components. This also reduces the need for future expensive repairs or replacements. Regular repair of the small hull also minimizes the potential of pollution and environmental harm to maritime ecosystems and coastal areas by ensuring compliance with environmental regulations and standard governing water discharge from aircraft carriers. Operational factors about water outflow from aircraft carriers include a range of elements that impact environmental impact management and mitigation. During regular operations and deployments, the small hull may release water that could introduce pollutants, toxins, or invasive species into marine environments, endangering the ecosystem's health, biodiversity, and water quality. As a result, naval forces employ strategies to reduce the negative effects of water discharge on the environment. These strategies include the use of cutting-edge wastewater treatment technologies, strict ballast water management procedures, and environmentally friendly operational procedures. Which brings us to the end of today's video. So if you enjoyed it, make sure you subscribe to the channel and like the video. Thanks for watching. We'll see you next time.